The Rocky Mountains in winter. Temperatures plunge to -30 degrees Fahrenheit. Howling winds strip heat from exposed skin in minutes, turning frostbite from a possibility into a certainty. The landscape stretches endless and unforgiving, blanketed in snow that can bury a man standing still. And in the 1820s, during the height of the fur trade era, mountain men ventured into this frozen wilderness for months at a time. They carried everything they owned on their backs. No permanent shelters, no heated cabins to retreat to when the storms hit. Yet these trappers didn't just survive the brutal Rocky Mountain winters. They thrived in conditions that would kill most people in hours. They discovered how to build what they called super shelters, simple structures that could create a 60-degree sleeping pocket in the middle of a -30-degree blizzard. This is how mountain men built super shelters to survive -30 degrees Fahrenheit Rockies winters without a cabin. Please share in the comments where you're watching from, and if you've ever experienced or learned any traditional survival skills yourself, we'd love to hear your wisdom. Subscribe for more ancient knowledge. The secret wasn't in the shelter alone, and it wasn't in the fire alone. The super shelter was a system, a carefully engineered combination that fur trappers in the 1820s Rocky Mountains discovered could mean the difference between waking up alive and never waking up at all. Many of these mountain men couldn't rely on permanent cabins during their months-long expeditions into the wilderness. They had to carry their survival on their backs, and what they created was brilliant in its simplicity. An open-faced lean-to paired with what they called a reflector fire, a specially constructed fire built not just to burn, but to throw heat forward like a furnace, with a wall of green logs positioned behind it to push that precious warmth back into their sleeping space. At -30 degrees Fahrenheit, danger doesn't announce itself with drama. It operates like a machine, mechanical and relentless. According to the National Weather Service, wind strips heat from exposed skin with brutal efficiency, and when you add wind chill to those temperatures, frostbite timelines shrink to mere minutes in exposed conditions. A stiff breeze at -30 degrees can create conditions where exposed flesh freezes in under 10 minutes. The mountain men understood this enemy intimately, and they built their super shelter system to fight back with physics. The hidden engine that powered their 60-degree sleeping pocket was radiant heat, the same invisible warmth you feel standing near a campfire even when the air around you remains cold. While most people think of fire as heating the air, the truth is that convection heat mostly rises straight up and disappears into the night sky. Radiation, however, travels outward in straight lines, and this is the heat that actually warms your body when you sit beside a fire. The mountain men learn to capture this radiation and focus it like a lens, creating a warm zone at blanket level even while the surrounding air remained deadly. The geometry was everything. Position the reflector wall wrong and the heat shoots uselessly into space. Build the lean-to too high or too low, and you either lose precious warmth or risk dangerous overheating. Angle the sleeping space incorrectly, and the wind becomes your enemy instead of your ally. But get the angles right, understand how radiation bounces and reflects, and you could create a pocket of survivable warmth in conditions that would kill an unprepared person in hours. This wasn't folklore passed down through romantic campfire stories. This was survival engineering, tested in conditions where mistakes meant death. The trappers who mastered this system could sleep comfortably in their wool blankets, while temperatures outside their shelter dropped low enough to freeze spit before it hit the ground. They had learned something that most modern people have forgotten. When you understand that a campfire warms you like the sun, by radiation, you stop building shelters like walls and start building them like mirrors. The materials were ordinary, almost disappointingly so. Any man with an axe and basic woodcraft skills could gather what was needed in a few hours, but the selection process revealed the mountain men's expertise. their understanding that survival engineering begins before the first log is cut. The secret lay not in exotic materials, but in knowing exactly what each component needed to accomplish. Site choice became the first and most critical material. The experienced trapper never built his super shelter in an exposed clearing, no matter how convenient it appeared. Instead, he sought natural wind protection, positioning his system at a timber's edge where trees could break the worst gusts, or against a rock shoulder that provided a natural windbreak, or along a cut bank where the earth itself formed a barrier. According to NOAA weather data, wind amplifies cold's killing power exponentially, making wind protection the foundation upon which everything else depended. Even a moderate breeze at -20 degrees could create wind chill conditions equivalent to -40 degrees on exposed skin. The ground beneath required equal attention. Smart trappers favoured dry ground whenever possible, but when deep snow made this impossible, they built an insulating base using whatever natural materials the landscape provided. Pine boughs, dry grass, even strips of bark could create a barrier between a sleeping man and the heat-draining earth below. The ground could steal warmth faster than the air above, making this insulation layer non-negotiable. Green logs formed the backbone of the reflector wall, and here the mountain men's material selection showed sophisticated understanding of fire behaviour. Green wood, freshly cut with high moisture content, resisted fast ignition compared to seasoned timber. This meant the reflector wall could sit close enough to the fire to be effective without becoming fuel itself. The green logs acted as a steadier, slower-changing thermal mass that could absorb heat during the fire's peak output and release it gradually as the flames died down. For the reflector wall construction, the system required 4 stout support stakes and a supply of green logs sized for stacking. Classic survival guidance described driving stakes approximately 1.5 meters into the ground and stacking logs horizontally between them. The most sophisticated builders created a double row arrangement, leaving an inner cavity that could be packed with dirt or stones, strengthening the wall while increasing its heat-holding capacity and reflection efficiency. The lean-to demanded different materials, but followed the same principle of purposeful selection. A strong ridgepole formed the shelter's spine, supported by angled rafters that would carry the weight of the covering material. The skin of the shelter consisted of brush, pine boughs, or whatever natural debris could be layered thick enough to cut wind and slow heat loss. Thickness mattered more than tidiness. Mountain men knew that appearance meant nothing when your life depended on the shelter's performance. The sleep system received the most honest attention, stripped of any romantic notions about roughing it. The wool blanket formed just one component of a layered system that included the insulated ground bed made from boughs, dry grass, or animal hides when available. This wasn't comfort, it was control of wind, moisture, and most importantly, the direction heat was allowed to travel. Construction began with laying out what the mountain men understood as the triangle of survival, 3 critical points that formed the geometric foundation of the entire system. The lean-to opening, the fire position, and the reflector wall behind the fire created a precise arrangement where each element supported the others. The fire had to be positioned so the sleeper could receive maximum radiation while remaining far enough away to avoid sparks and dangerous overheating. This distance typically measured several feet, adjusted based on fuel type, wind conditions, and shelter size, but the experienced trapper could judge it by feel, knowing that too close meant burns and too far meant freezing. The lean-to itself was built open-faced by deliberate design, not because the builders lacked materials for a full enclosure, but because the physics demanded it. For a single sleeper, the optimal dimensions had been tested through trial and potentially fatal error over countless winter nights. Length stretched roughly 7 to 8 feet to accommodate both body and essential gear. Height at the opening measured 3.5 to 4.5 feet, a low profile that conserved precious heat while Reducing wind entry points. The roof angle followed a moderate slope, often around 45 degrees, calculated so the interior surface could see the fire directly, catching radiant energy instead of allowing it to escape uselessly into the night sky. The Reflector Fire and its back wall formed the system's heart, requiring specific construction techniques that separated expert builders from those who merely survived. The fire itself needed to be long and steady rather than tall and flashy, built for sustained heat output during the long hours when the trapper would be asleep and unable to tend the flames. Behind this carefully planned fire, the reflector wall rose according to field-tested specifications. 4 stakes, each approximately 1.5 meters long, were driven deep into the frozen ground to form the wall's framework. Green logs were then stacked horizontally between these stakes, creating a solid barrier that could withstand heat without igniting. The most sophisticated builders created what amounted to a double-walled system, constructing 2 parallel rows of stacked logs with a cavity between them. This inner space could be filled with dirt, stones, or other dense materials that would absorb heat during the fire's peak burning periods and release it slowly as the flames died down. The physics was straightforward but critical. A wall behind the fire reduced backward heat loss and pushed thermal energy forward toward the sleeping space, exactly like the parabolic reflector in a modern flashlight focuses light into a beam. The sleeping bed received construction attention equal to the shelter itself, because the mountain men understood that ground contact could drain body heat faster than air exposure. The bed had to function as floor insulation, just like in a permanent house. Thick layers of pine boughs, dry grass, or salvaged materials created a barrier that could mean the difference between waking up warm and waking up with hypothermia. The shelter wasn't designed to block cold anymore. It had become a precision tool for aiming heat exactly where human survival demanded it. The hidden sophistication of the mountain man's super shelter lay not in its appearance, which looked crude to untrained eyes, but in its mastery of thermal radiation, the same invisible force that allows the sun to warm Earth across 93 million miles of cold space. When a trapper sat beside his campfire, the warmth he felt on his face came primarily from thermal radiation, not from heated air. The hot air produced by combustion rose straight up and disappeared into the night sky, but radiation travelled outward in straight lines, carrying energy that could be captured, redirected, and controlled by those who understood its behaviour. The heat trap concept that made the super shelter possible operated on 3 interconnected principles that transformed a simple lean-to and fire combination into a precision heating system. The reflector wall prevented backward heat loss, acting like a mirror that bounced thermal radiation forward instead of allowing it to escape uselessly into the wilderness. The lean-to roof and inner surfaces absorbed this redirected radiation and then re-radiated a portion of that warmth back toward the sleeping trapper's body, creating multiple layers of heat exchange. The low roof design reduced the volume of air that could be stirred away by wind, maintaining a smaller, more manageable thermal environment. Thermal mass played a crucial role in converting the system from a blast furnace effect to a steady heater that could sustain warmth through the long hours when the trapper slept. The dirt-packed log walls, along with carefully positioned stones when available, absorbed heat energy during the fire's peak burning periods and released it gradually as the flames died down to coals. This thermal battery effect smoothed the dramatic temperature swings that would otherwise wake a sleeping man as his fire burned through its fuel load. Wind management separated successful super shelter builders from those who froze despite their best efforts. The entire system had to be oriented with the open face positioned away from prevailing wind patterns. According to NOAA research, wind both chills exposed skin through convective heat loss and steals thermal energy from the shelter's boundary layer, the thin zone of warmed air that forms the interface between the heated shelter interior and the deadly cold outside environment. Fire longevity required different construction techniques than the cooking fires most people understood. The overnight heat fire focused on thicker fuel arranged in configurations that kept coals alive rather than producing dramatic flames. The difference between a cooking fire and a sleeping fire was the difference between a sprint and a marathon, each demanding its own fuel selection and laying patterns. Safety considerations demanded sober attention in a system that combined open flame, flammable shelter materials, and sleeping humans. Sparks, smoke accumulation, and runaway ignition represented real risks that could transform a life-saving shelter into a death trap. Proper clearances, strategic use of green wood near flame sources, and careful management of combustible materials within the fire's throw zone separated experienced practitioners from those who learned these lessons too late. What appeared primitive to modern eyes was actually heat engineering built from wood, dirt, and hard-earned judgment. The men who perfected these super shelter systems were products of a unique historical moment, the Rocky Mountain fur trade era that peaked in the 1820s and 30s, when economic opportunity drove ordinary Americans into wilderness conditions that would challenge modern survival experts. These trappers carried everything they owned on their backs during months-long expeditions into unmapped territory, traveling light by necessity and facing constant demands to improvise solutions with whatever materials the landscape provided. According to educational resources from the Buffalo Bill Center of the West, mountain men had to hunt their own food, build temporary shelter systems, and repair essential gear using only what they could carry or fashion from natural materials. The absence of permanent cabins wasn't a romantic choice, but a practical reality driven by the economics and logistics of the fur trade. Cabin construction required enormous investments of time and labor that most trappers simply couldn't afford during their brief seasonal windows of opportunity. Many camps were temporary by design, positioned to exploit specific trapping opportunities that might last only weeks before the men moved on to new territory. Others were seasonal camps that would be abandoned when weather or animal migrations demanded relocation. The mobile nature of the trade meant that survival knowledge had to be portable, reliable, and adaptable to whatever conditions the wilderness presented. The sophisticated shelter techniques that emerged from this era reflected a crucial exchange of knowledge between European-descended trappers and indigenous peoples who had developed cold-weather survival methods over countless generations. Historical marker accounts describe how trappers often spent entire winters with friendly native bands, not just trading for furs, but learning environmental knowledge that could mean the difference between survival and death. These extended stays provided opportunities to learn local food preparation techniques, understand seasonal weather patterns, master regional travel networks, and absorb shelter-building methods that had been tested and refined through centuries of harsh winter experience. This knowledge transfer deserves respectful acknowledgement rather than the romantic mythology that often surrounds mountain man stories. Many of the techniques that became associated with fur trapper survival were actually strengthened and improved versions of indigenous methods, shared by native peoples who understood that survival knowledge benefits everyone when harsh conditions threaten human life. The super shelter system, with its sophisticated understanding of thermal radiation and wind management, likely incorporated principles that had been developed and taught within indigenous communities long before European contact. The learning networks that developed during the fur trade era created a unique environment where survival knowledge traveled efficiently between cultures and individuals. In the Rocky Mountains, information flowed along trade routes and through temporary camps where men shared techniques that had proven effective in life-threatening situations. Knowledge moved the way rivers flow, finding the fastest route from those who had learned through experience to those who needed that information to survive their next winter in conditions where mistakes meant death rather than mere discomfort. The reflector principle that made the mountain man's super shelter possible proved universal across landscapes and cultures, adapting to whatever materials each environment provided while maintaining the same fundamental physics of heat redirection. In the Rocky Mountains, green logs formed the classic reflector wall, but Arctic peoples built similar heat-focusing systems using packed snow blocks that could reflect thermal radiation almost as effectively as wood. Desert survivors in the American Southwest constructed reflectors from stacked stone that absorbed heat during the day and radiated warmth through cold desert nights. Plains Indians used earth banks and buffalo hide arrangements to create heat traps around their fires. The material changed, but the engineering principle remained constant. Create a surface behind the fire that pushes thermal energy forward instead of allowing it to escape uselessly into the wilderness. Regional variations of the shelter itself demonstrated the same adaptive flexibility while preserving core thermal management concepts. The fastest build version paired an open lean-to with a simple reflector, perfect for overnight stops during travel. When materials were scarce, survivors created effective systems using just a windbreak combined with fire and reflector, sacrificing some comfort for speed of construction. More permanent camps featured deeper debris shelters that used external fires for heat while providing safer spark control, allowing larger fires without the constant risk of shelter ignition. Each variation addressed specific environmental challenges while maintaining the essential geometry that made radiant heat capture possible. The physics underlying these systems found validation in modern thermal science and emergency survival equipment. The United States Forest Service explains that wildfire emergency shelters protect firefighters primarily by reflecting radiant heat away from human occupants while trapping a layer of breathable air, proving that reflection-based heat management represents applied thermal science rather than primitive folklore. The same principles that allowed mountain men to survive -30-degree nights continue to save lives in modern emergency situations where advanced technology fails or becomes unavailable. Contemporary survival doctrine maintained direct connections to these historical techniques, demonstrating their continued relevance in an age of high-technology outdoor equipment. Modern military and civilian survival manuals still teach improving lean-to shelters in cold weather conditions through the addition of fire reflector walls, creating an unbroken line of instruction from 19th century mountain man practices to current institutional survival training. The United States Army Survival Manual, various wilderness education programs, and emergency preparedness organizations continue to recommend reflector fire techniques as reliable methods for extending human survival in cold weather emergencies. The enduring effectiveness of these methods highlights a crucial survival principle that transcends historical periods and technological capabilities. Different centuries produced different people facing the same fundamental challenge of maintaining human body temperature in environments that could kill through heat loss. But the solution remained remarkably consistent. Whether you examined 18th century fur trappers, 20th century military personnel, or 21st century outdoor enthusiasts, the truth remained unchanged. If you cannot carry a house into the wilderness, you must carry the engineering principles that make a house work. Three fundamental principles emerged from the mountain men's super shelter system, lessons earned through nights when mistakes meant death and success meant waking up alive to see another dawn. Block wind first because according to NOAA research, wind transforms survivable cold into lethal conditions faster than any other environmental factor. A man might endure -20 degrees in still air for hours, but add a 15-mile-per-hour wind, and the same temperature becomes immediately dangerous to exposed skin. The experienced trappers understood that wind was the great thief of warmth, stealing heat from both human bodies and shelter systems with mechanical efficiency that never tired and never relented. Insulate from the ground became the second non-negotiable rule because sleeping warm had to start from underneath. The Earth could drain body heat faster than the surrounding air, turning even the best upper body insulation into a futile gesture if the sleeper lay directly on frozen ground or snow. The thick bed of pine boughs, dry grass, or salvaged materials wasn't comfort. It was survival engineering that prevented conductive heat loss from turning a warm, sleeping human into a hypothermia victim during the night hours when the fire burned low and body metabolism slowed. AIM radiant heat represented the third principle that separated those who merely had fires from those who used fires as precision heating tools. Most people understood fire as something that warmed the air around them, but the mountain men learned to think of their fires like focused sunlight, directing thermal radiation exactly where human survival demanded it. The reflector wall, the shelter geometry, and the careful positioning of the sleeping area all served this single goal, capturing and redirecting the invisible energy that could maintain life in conditions where ambient air temperature alone would kill. These three rules formed more than survival techniques. They represented a deeper understanding about human problem solving that modern society had largely forgotten. The Mountain Men's super shelter system demonstrated that extreme environmental challenges could be solved through careful observation, geometric thinking, and intelligent use of local materials rather than through overwhelming technological superiority. Their solutions required no manufactured components, no external energy sources, and no supply chains that could fail during emergencies. Instead, they relied on understanding natural physics and applying that knowledge through disciplined construction techniques. The broader lesson for contemporary audiences lay not in romantic nostalgia for a simpler past, but in recognition of human adaptability when guided by sound principles rather than convenient assumptions. These men faced environmental conditions that would challenge modern survival experts equipped with advanced materials and communication technology, yet they developed reliable systems using nothing more sophisticated than axes, knowledge, and the materials that surrounded them. Their success came not from superior physical toughness, though frontier life certainly demanded that, but from superior understanding of the relationship between human thermal needs and environmental physics. The Mountain Men's super shelter stands as a reminder that human beings once routinely solved life-threatening problems through geometry, local materials, and careful observation of natural processes. These solutions emerged from silence and cold, built by people who understood both the landscape they inhabited and the knowledge systems of those who had learned to thrive in that same landscape long before them.